Simon, I was looking forward to this one.
Hi, Paolo.
So you and I know each other fairly well, right? So, but
Indeed. Yep.
we have never had this kind of conversation, right? And and it's interesting. It's something different. We usually have guests and people who are very active in the world of chemical research. You obviously have a lot of experience in that, but your current job and what you've done in the last few years is different. You're coming more from an industry, but we are evolving our season 4, and I think this is going to be a fun one. So again, very happy to have you with us.
Thank you.
So you know our format, right? You know what we want to do. We want to dig between the relationship between the person and the science, right, and the technology. And the way we traditionally start is just trying to just put together the story, right, the path. So and this is something I genuinely don't know because I've never had the opportunity to ask you, but uh, where did it all start from? How did you stumble across chemistry? How did it happen for you?
Well, I'd like to say that, I was given a chemistry kit by my parents when I was sort of 8 years old, and that started, the sort of lifelong desire to be a chemist. But if I said that, I'd be lying, if I'm honest. I did have a chemistry kit when I was younger. I can remember that. Probably a lot of the chemicals in the kit would not be allowed to allow children to handle them these days, I guess. But back then, I can remember there was some copper salts and some various other things
Mm.
which that we could work with that was in this kit. But no, it's really by chance, if I'm honest. So I took a general sort of suite of exams when I was 16, and actually my favourite topics were English and history, so not science at all. But I thought if I took science at kind of advanced level, then I had a better chance of getting a job. Frankly, that was kind of my feeling back then at the age of 16. And so I took advanced levels in chemistry and biology, and actually I didn't do very well, if I'm honest. So I had through those 2 years it was quite difficult. My father became very ill, and so the kind of the home life changed, and there was a lot going on. And at the end of the day, I actually got an F in chemistry, A level.
This is
So I actually
unbelievable.
failed my chemistry. So that was a really bad start, but we'll keep that between ourselves, Paolo. Don't
Yeah, there's only a
mention it
few
to human
thousand listeners.
resources.
There's only a few
Yeah,
thousand
yeah, yeah,
listeners.
exactly,
Yeah, yeah.
exactly. We don't want human resources to know about that. They might, dock my salary or something. But I had an F. But the school were aware of the challenges I had, and they found a job. I was looking for somewhere. I wasn't going to go to university, and I really needed to find some work. So I actually finished my exams, I think, on the Thursday at school, and started full time on the Monday in a full time job as a laboratory assistant. So no gap year for me, no traveling around the world. I went to work, and as that laboratory assistant, I still wasn't doing any real chemistry. I was doing some weights and measures. I was working for a company that made car care products back in the early 1980s. There was really a desire for people to customize their vehicles, their cars, and we made a lot of products that people could use for that. And so I was involved in that. And I worked there for about, I guess, 18 months. And during that time, I took what was a higher national certificate in chemistry, kind of day release course that the company allowed me to do. So I kind of carried on with my education, but part time whilst I was working. But after about 18 months, there were some changes within that company. I got made redundant, so I was looking for a job, and I was looking in the local newspapers, and I saw this job for assistant chemist at a company called Maybridge, and I thought, well, I have some laboratory experience. I've got about 18 months working in a lab. I hadn't really done any chemistry in that time, but I at least can apply. No harm there. So I applied for the job as an assistant chemist, and was interviewed. I remember what was to become my manager, Dr. Ken Morris, who was a very good organic chemist. By the way, he interviewed me, and at the end of the interview, he said, "Well, I'll give you the benefit of the doubt. I'll give you a chance." And so it was, and that was an opportunity for. So I started work at Maybridge, and that was in January the 31st, 1984. So kind of unbelievably to me, 39 years ago, in a couple of weeks' time. And and really, that was a job where I was doing organic chemistry, but I really didn't have any formal training other than what I'd done at school, and a little bit through the part-time course. So it was a steep learning curve, I can tell you, for for the first couple of years at least, working at Maybridge. But I managed to kind of to learn a lot about the skills that I needed to do the practical chemistry and understand how to make molecules, and that really kind of got me on the path that 40 years later, here I am.
And you've seen the chemical industry evolving, right, in these 40 years. So it must have been an incredibly fascinating journey if you stop and look back. I don't know how often you do that. Do you ever stop and think and rebuild it in
Oh,
your mind?
yeah, absolutely. I mean, funnily enough, we were during the period of time I was with Maybridge. Obviously, the business grew a lot, and that at one point we were a family business. Then became owned by venture capitalists, and at that point we actually had a visit from Her Royal Highness Princess Anne. And she came to the lab and she spoke to me and she asked me what changes I'd seen in chemistry. And this was in the mid noughties, I guess, and obviously since the 1980s. And I said, well, the main thing was, of course, the introduction of computers. When I started in the lab, we still wrote everything down. We had file indexes. We really didn't use computers to figure out methods. We had journals, actually physical journals would be delivered every month. So we'd have the Journal of Organic Chemistry, Journal of Heterocyclic Chemistry. A lot of our chemistry was really biased towards heterocyclic work. Journal of American Chemical Society. All of these journals would be delivered. We had a library where the journals were stored. So you could go and you could search for methods. You could go and look at the new journals as they came in, see what new methods were being, new compounds were being synthesized, new methods we could adapt to our own chemistry. So all of that was very, was kind of old school, I guess, in the sense that you were using paper journals and all of that, all of what you did was really, I guess people describe the art of organic synthesis, and it was an art in those days, certainly, because you really had to kind of figure out the best method to get to a target molecule, kind of from your own efforts. These days, there's a lot of help, I guess. A lot of computer tools out there, a lot of databases of methodologies you can access and find the routes that you need. So that's definitely a big, through my career, a big change in terms of the number of tools there are now. And of course, we start talking about AI and
Oh yeah,
robotics
well,
in chemistry in the future. Looking even more exciting.
yeah. Things are mind blowing if you think where it might go from here. But Maybridge was probably a quite a unique thing, right? It was at the, well, it was really at the forefront of innovation back then, right? And I guess for as a perfect place for learning chemistry because Maybridge was just developing these screening libraries. There was a lot of chemical diversity, so I'm assuming you were running a lot of different reactions. So it's the perfect place for an organic chemist to be and kind of learning on the job, isn't it?
Oh, absolutely. And we so Maybridge was a little bit of background, perhaps maybe. So Maybridge was founded by Dr. Roden Bridgewater, who was a professor at Guy's Hospital, and then he wanted to bring his family up in Cornwall, which is where I'm from, where I live. And this is kind of people are not that familiar. Is the kind of extreme southwest of England. It's not a big area where there's a lot of high tech jobs, and so he needed to create sort of his own business, and so he founded Maybridge. Maybridge was named after his wife, May Bridgewater, and so that was how the company's name came about. And he had some contacts in both the sort of pharmaceutical industry and the agrochemical research industry, and he really understood there was a requirement for molecules, predominantly heterocyclic molecules for screening. for against to discover new drugs or to discover new pesticides or herbicides in the agrochemical world. He set the business up and it grew slowly. But when I joined in '84, I guess maybe there was about 20 chemists working there, and we were pretty much given free reign to create what we liked. We just had a very simple rule. Sounds odd today, but we were very clear. We had to make 3 times our salary plus 10%. So we had to sell enough chemicals to make our salary plus two more. This covered the overheads, and this was kind of the rule. And pretty much as long as you did that, then you were good, and you could just carry on and make. So of course it favoured people who kind of understood what the customers wanted. You couldn't just make any old chemical. You had to make something that customers desired, wanted to buy, and you could kind of work that out almost by trial and error. But offering the compounds to customers, we used to offer. We would make a series of compounds, maybe 20 or 30 analogues of around a particular molecule that we'd synthesized, new molecule, and then we would offer those to a customer, and they would say whether they wanted to purchase them or not. And so we kind of knew what sort of molecules the customers were interested in, and we'd sort of target our chemistry around there.
And this is interesting.
But yes, we did a lot of different chemical reactions, although I started my career, unfortunately, working with files. So those of you who may be familiar with files, the kind of key feature of a file is the smell. They actually use methane file in natural gas to give it its smell, a very small amount of it, but they are incredibly strong smelling compounds. And I did a lot of chemistry in the early days with files, probably because no one else wanted to touch it, which is probably, explains why I was single for a long time in my early 20s, because I was working with files. But I did enjoy, a lot of the opportunity to create a lot of different molecules. And I had one my kind of one party fact about files, which I always share with people that I particularly remember. I don't know if you know the original word for file is mercaptan.
Yep.
And mercaptan, the reason for mercaptan is it's Greek. It means mercury capturing, and the reason for that is because the only real difference between a file, an SH, and an alcohol, an OH, apart from the smell, is that files react with mercury compounds, but alcohols don't. So this was my. So there we go. That's a fact for today. At least if you learn nothing else.
I like that. And now I remember that you told me this one, and I didn't know it before, but I forgot about it. So now I need to write it down, so I will remember. and it's a good. And I know you have another story about thias, but we'll get there later. It's more of a funny one, but if I think about how you got there, it feels quite incredible to me, and probably something that would be almost impossible today, right? I guess how much of it must have been terribly difficult for you to get there as a sort of inexperienced chemist and getting involved with fairly advanced complex chemistry, dealing with heterocyclic compounds and doing thiochemistry and stuff that can also be quite dangerous. And I know you had like 20 colleagues that are probably further ahead in terms of their training and experience. It must have been dauntingly difficult. How did you overcome those days? How did it look back then? Was it just adventurous? Or?
It was. I mean, I think it was at least 2 years from when I started work really to when I stopped panicking almost. I was struggling. It was tough. I as I said, I didn't have a great deal of formal education. Most of the colleagues I worked with had at least a minimum of a degree in chemistry. Many of them had PhDs in chemistry. So I was unusual in the sense that I didn't have that formal education. I was learning all the time. We were doing lots of different chemistry. I was very lucky to be able to learn with some very good chemists who were working at the company at that time. and they were very, kind to be able to sort of share their knowledge with me. I think sometimes they were somewhat frustrated at my sort of lack of knowledge, but I was able to begin to really to get, I would say, a good knowledge of the different chemical reactions that I would need to do, and then I was able to use them to kind of work out quite complex problems in terms of molecules that target molecules that we were being asked to synthesize. I think one of the other things that I discovered about myself actually at that point that I think was kind of as key to sort of to my later successes perhaps is I'm quite a good administrator. So this is kind of not a scientist, but an administrator. So I was able to kind of figure out the best way to plan my day. I would be planning, a week in advance what reactions I was going to do, what reagents I needed, what starting materials I needed to get, what equipment I needed to pull together. So I was very productive. So that was really that made me very useful to the people that I was working with, because they knew that I could get a lot done and I could get it, and I was very reliable in that sense. And so they discovered that if actually not only if they gave me certain tasks or certain reactions that they happened very, very quickly, but also if I was managing a team of people, the same was true of that team. So obviously that then kind of moved the direction to say, okay, you need to be managing a group of people. So I kind of went, and it took several years, and I guess probably 5 years into my time with Maybridge, and I by that time I had a team, and that team was very successful. And again, going back to the 3 times your salary plus 10% rule, the same is true of a team. If you're running a team of people, it's 3 times the salary of the combined team plus 10%. So, but if you could do more than that, if you were more successful and you could create sort of 5 or more times, obviously then more and more chemists would be handed to you or given more kind of authority to do more in terms of the business. And so kind of, it was a combination, I guess, of learning the actual chemistry skills and how to organize myself and then the team that really, allowed me to be very productive and to get a lot done. And that clearly was in the early days of the business. We were, a business that was there to support our customers and to make money. It's a commercial business. We weren't doing research for kind of an interesting molecule. If you got to if there was a particular target that you wanted to make, but you tried a few attempts different ways and you were unsuccessful, you gave up. You didn't spend a lot of time working on that. You had to move on to the next thing. And that was the way it was.
And it is so different than working in an academic environment where you just pursue the discovery, and even a failed experiment is a learning. Well, it certainly is in industry as well, but as you always had this sort of profit target to hit, right? And then you just can't sleep. It's life or death at some point, which is really interesting. What's interesting is also that this productivity aspect that you highlight is something that a lot of our guests actually speak about, right? And it's very often the difference between the success or failure for people in any career. And it's interestingly enough things they don't teach you usually. You just need to learn on the job. So you kind of have it in you or you don't. It's kind of interesting. Do you think you've been lucky at the very beginning? Because it must have been a bit tricky for Maybridge to find qualified personnel in Cornwall, right? It's not like being in, I don't know, in the Cambridge area or I don't know, in Oxford or whatever, London, where there's plenty of people. It must have been tricky from the sort of HR perspective, from the recruiting perspective. Do you think there's an element of luck there? Yeah.
Yeah, absolutely, and I'm sure that was one of the reasons why they took the chance with me in the first place. I mean, we always struggled. The site was a very remote site. It's a place called Trevillett, which was on a hill above. People may have heard of Tintagel or Tintagel Castle and King Arthur. There's the sort of the the legend there. But we were a small site. It used to be a slate quarry, and so the buildings were kind of industrial, but they were abandoned, and they were taken over for our factory. So we were, remote. I mean, the nearest cinema was probably 30 miles away. There was no nightclubs. There were very little to do. So for younger people, it was quite a remote place to be to be looking for to work. And we did have a group of younger chemists, and particularly if you were into the surfing or the sort of
Right.
that style in the summer, then Cornwall is a great place to work and to live. In the winter, not so much. And so we were actually a close knit community. But yes, it was a struggle to recruit people down. We did, and I guess the ones that also where we were successful because of the again, to comment on the freedom we had to kind of create our own chemistry, to do our own thing. We weren't following anyone's direction particularly. We could make the molecules that interested us. So there were a group of chemists who really enjoyed that freedom, and it was worth to come to a kind of fairly remote place to be able to do
Yeah, of
that. Whereas
course.
maybe in a larger, more formal organization, they would have a lot more constraints, in terms of what they could actually do.
And it's kind of rare in an industrial setting, right? Because very often the research programs are so tight, right? Because you have like very specific objectives, so there's a bunch of people working on similar things, and the the definition of success is very narrow. I mean, what was interesting of that job is there was this sort of product management perspective to it, right? So it's kind of deciding where to take your compound libraries, right? Hoping or knowing that you would have found customers' interests. Um, that's quite a learning to have, right, in this industry.
Yes, absolutely. And one of the things that we, as I said right at the beginning, we didn't have sort of the computers and the ability to kind of necessarily to record what we were doing in a way that we could share. And so we all worked in different areas of chemical space, mainly so we weren't actually kind of say copying one another, but actually kind of recreating work that had already been done.
Mm.
So each team kind of worked in its own area. So I, for example, focused on thiophene, furans, and pyrroles as different heterocyclic rings because I knew that was an area that no one else was working in at the time. Um, and so this actually, of course, led in ultimately to the fact that we have such a diverse set of screening molecules in the collection today, because the history of the screening collection came from small groups of chemists working for ultimately decades, actually, because the
Yeah.
business was founded in the 1960s. In sort of in different areas of chemistry, making different compounds, and so that was something that you had to figure out. What areas you were going to explore, what compounds you were going to synthesize next, and commercially how that what customers would be interested in those products. Because if it's an agrochemical customer, they might be interested in a certain group of
Certainly.
products. If it was a pharmaceutical customer, it would be a different group of products. So yes, it not only gave you some insight into the actual chemicals, but also into the kind of the commercial landscape too of what compounds were important to different groups of customers and what they saw as being, important for their research.
And back then, between the 80s and the 90s, I mean, that was the time when the pharma companies started looking into, chemical diversities. There were a lot of people getting into the sort of combinatorial chemistry. So this is where chemistry went more brutally, right? Or with more brute force into exploring the chemical space. And that's when, these screening libraries became extremely popular. So I guess Maybridge was quite at the forefront back then. And were there many other companies doing similar job? And what do you remember of, where the spirit of the scientific community was back then?
So I think we're actually quite unique to begin with, mainly because there were, I mean, we didn't set out to create a collection of screening compounds. We were
Right.
making small groups of molecules which we were selling directly to different customers. But if you it kind of is it's funny now, but the quantity of compound we used to sell to a customer for screening back in the 1980s was 2.5 grams. Now, today, to put that into context, if we sell 1 milligram or 5 milligrams, that's plenty for a customer to be able to do multiple screens. But back then, the technology wasn't so sophisticated as it is, and they were buying multiple grams. But if we have to provide 2.5 grams to a customer, then as a chemist, you're obviously going to synthesize ideally more than 2.5 grams. You don't know what the yield's going to be, so you kind of overestimate. You make sure I have plenty, so maybe we get 10 grams of material. Then we sell our 2.5 grams to the customer. What do you do with the 7.5? Well, you put it in a bottle and you put it on the shelf, and that's what we did for tens of thousands of compounds over the years. So we ended up in sort of the mid 1990s, I guess, with a collection of about 55,000 compounds, multiple grams, all of which were solids, all of which were fairly inert.
Yeah.
They weren't chemically reactive. And as you say, the big pharmaceutical companies were at that point looking to acquire additional screening compounds because the automation was starting to kick in terms of the large volumes of compounds they could screen very quickly. But of course, synthesizing enough compounds is a challenge. So acquiring commercial compounds was an opportunity. So we had a lot of business, and the business grew very quickly through the 1990s. On the back of that, and there weren't really that many other companies that had that kind of collection of compounds. So because if you were to look at sort of the 1980s or the landscape of the 1980s, then pharmaceutical companies, I would say in sort of Europe and North America, Japan, they were doing pharmaceutical research as sort of big business, and they had their in-house collections, which they were adding to from commercial vendors like ourselves. And then if you looked at sort of like Eastern Europe, you still had the Soviet Union at that point, and their model was very different, and it was very state-sponsored. But obviously, after the sort of the fall of the Soviet Union in kind of the early sort of I guess 1990s, there was a real change in terms of kind of larger organizations came out of that that had much larger collections. And we take, let's say, the world leader perhaps in building blocks and screening compounds today, Enemain, who are a Ukrainian company, came out of kind of that period, but not the only ones. So that's kind of how the business kind of changed. But yes, back in the 1990s, we were in very strong position. We had some interesting molecules, and obviously that led to us winning in 1996 the Queen's Award for Export. So that was a big opportunity for the business, but also it then led to some significant changes, not least the family stepping back, venture capitalist business, purchasing what was the Maybridge business, which ultimately led, of course, to the point where today we're part of Thermo Fisher Scientific.
How was the change back then? How did you live it?
I guess it was it was very interesting. I mean, I mentioned that it's coming up for 39 years since I joined Maybridge, and so people say to me, 39 years, that shows a staggering lack of ambition. But I've worked for the same company on paper at least, but not really. In fact, because I started work for a family business, and then they were acquired by venture capitalists. A company called Free Eyes with the Royal Bank of Scotland bought Maybridge in 1997 after we won the Queen's Award for Export. So then the business changed radically because the family who were more or less running things, it was a traditional family business. They all stepped back. They did very well from the sales, so they got some race horses and they went off and raced those, and the venture capitalists brought in a professional management team. And what do you do if you're a venture capitalist company and you've just acquired a sort of a chemistry business? You look and see what is the number one sort of chemistry catalog business in the world back then. It's probably now Sigma Aldrich at the time was, and they said, okay, what we need is some people from that organization. So they headhunted some key people from that business, and they parachuted them into our business as the new management team. So we had a completely new management team, and obviously, as venture capitalists do, they invested a lot of money. So they built new facilities, new labs. They invested in a commercial organization, and then really it was at that point that I started to kind of, I guess, become more involved in or step away from the lab a little bit. In the first instance, really working with consultants to kind of to restructure the chemicals business to be a lot more modern. Moving away from the kind of the 3 times your salary to plus 10% to a unified chemistry business that was actually all working together as one single team to deliver, what the business needed, a business that was rapidly expanding. So yeah, very significant changes, at that time. And obviously after 5 years, they then sold the business to what was Fisher Scientific before we became Thermo Fisher.
Yeah.
So back in 2003, we were still Fisher Scientific, and so that's and then again, so significant changes when you're owned by a kind of a US international company like Thermo Fisher. So yes, very very distinct changes over the years as the business evolved.
Do you ever miss your days in the lab?
Oh yes, I think all of us who've done chemistry, we certainly, I enjoyed the creativity of it. I enjoyed the kind of the designing of the molecules and the success, the great feeling when you actually synthesized something that you actually set out to make. Sometimes they were quite challenging. So yes, I do miss that. But it was kind of an evolution for me. I spent about 16 years in the lab. Okay, I ended up as from kind of starting as an assistant chemist with kind of basically washing out the glassware in the lab and doing fairly general jobs, to chemistry manager. I had several teams reporting to me. I was kind of I had my last sort of significant chemistry job. I actually had 32 chemists working on a single project for a large pharma company. I do remember kind of a couple of the last projects I had actually. I think show the breadth of the sort of the chemistry that we did, because I had 2 projects. One was actually a diabetes diagnostic kit. So this was a chemical compound that went into a kit that was able to measure blood sugar levels, and it was kind of an electronic device that was able to tell you whether your blood sugar was too low or not. So that was a medical device, but then at the same time, I was also working on another project for a toy company in Canada. So this company were making, their project was a toy bubble, like a soap bubble that you blow. And but this bubble, I think they called them Zubbles when they marketed them. It had a primary color like a red or green color, and you blew that, and you could see this colored bubble, and then the color disappears, right? So you don't get a nasty red stain on your mother's kitchen surface or whatever. But it was down to an indicator dye that was in the bubble solution, and the large surface area of the bubble meant that as it drifted through the air, it reacted with the oxygen, and that reduced the pH, and the color disappeared. And so that was another project that we were involved in. So very different, both chemical, both heterocyclic compounds, one in a really kind of a key diagnostic kit for medical device, and another a kid's toy. So kind of shows the breadth of how chemicals can be used.
It's a beautiful example of what we always try and say. Chemistry is everywhere, and and even more organic chemistry, right? Because it's such a foundational science and sometimes overlooked, but it's really all around us, and it's fascinating. It's a couple of brilliant examples here. Thanks for that. From how you have described, your experience in Maybridge from your early years into the later ones, and it's always pretty obvious to me, but I asked the question anyway. In your current product management job, a lot of your attention is in kind of trying and understand where the market is going and trying to identify new products that are of interest for the market. And I can see how your experience, in Maybridge as a chemist who had to kind of manage his work in terms of figuring out what was of interest. Yeah, it gave you the mindset probably from the very beginning, and that might have probably been quite unchanged over the years. But and I guess this must be one of your stronger learnings, right? What else in your sort of path you feel like you're using a lot to these days?
Well, I think one of the kind of key changes, within my career, thinking back when I sort of stepped outside of the lab, and I sort of got more involved in the sort of I guess the management of the team and the sort of evolution of the team. That led to me being kind of asked if I would go out and talk to customers about the work that we were doing or the work that we could do. Right, so I started to travel more. So I sort of and I often say, Polo, that this is at the moment perhaps when I'll turn to the dark side of the force, as some of my colleagues who remained in sort of chemistry would sort of describe it. But I sort of took off my lab coat, I put on a kind of a smart jacket and set off. And I can remember actually the very first trip that I made, and this was quite new, because I hadn't come from a formal background where I'd kind of been to university, maybe taken part in sort of conferences and speaking. And then one of the very first things I was asked to do was to go to Switzerland. I remember going to Basel to give a seminar as part of a conference. We were sponsoring the conference, so they'd offered us a speaking slot, and so someone said, "Well, we need someone to speak," and none of my colleagues were keen on the idea of going to Switzerland and talking about our chemistry. So, I volunteered to do that, and that was kind of I kind of remember sitting on the plane and thinking, what have I got myself into, right? I have to say, it was a bit of a disaster, if I'm honest, because it worked out okay in the end. But I was the second speaker on the first day, and this was at the Hilton Hotel in Basel. So it was a very kind of grand setting. They had a really nice lecture theatre kind of down in the sort of the basement of the hotel. There were maybe 200 people. And I was sort of sat at the front nervously thinking, oh, heck, what have I got myself into here? But there were 3 speakers on each session, and there was obviously, as often with these, there was someone moderating the session, and so they were kind of careful to sort of say, okay, we need to make sure we finish on time, don't overrun your slot. And I think I was actually the third speaker on of the 3. So anyway, long story short, the second speaker overran quite a bit, and the moderator was kind of was not happy, because we were looking at the sort of coffee time, and we were going to be running into that. And so I got up to deliver my third the third talk of the morning, the final one before the coffee. I was so nervous, I just charged through it at 90 miles an hour, right? I don't think and so it was pure nerves and adrenaline. That was kind of what it was. But at the end of it, the moderator thanked me profusely for finishing my talk so quickly and actually bringing us in on time. She said it was really professional, fantastic job. So again, luck came to my aid there. But that was kind of my first experience. But having done that the once, then I got invited to do it a lot more, and obviously, the travel became a lot more much bigger part of my job. And I've been very lucky to be able to go all over the world and meet many customers and talk to them about their research and the products that they use. And so that from not only from my I guess from my own chemical experience and being able to talk often to chemists about chemistry, because I have 16 years or so in the lab, so I I know what the challenges they're facing very often, but also the opportunity to kind of see the different researchers and different areas of chemistry in different labs around the world has really given me great opportunity to bring that to my current role, to be able to kind of know what I believe we are offering in terms of the products and services that we offer today.
Yeah, absolutely. People say that chemistry is somehow a sort of slowly evolving science, or even a science which is dead in the sense there's not much going on, right? And perhaps that's an impression you can get if you compare it to some of the biological sciences that are so progressing so fast. Think about genetic sciences, and some of the molecular biology. How they've changed the world, and how much is going on at the moment. But the reality is that there's a lot going on even in organic chemistry, right? And if you think about how you did compounds, just a few years ago, or how organic chemistry looks today, and how it looked back in the 80s, I guess it's pretty different. What's your perspective? It's quite a unique opportunity to speak with someone who's seen it all.
Well, I think absolutely. For a start, I think you've got to kind of separate the organic synthesis from sort of if you like, the organic chemicals and
Sure.
the chemistry, because synthesis itself hasn't changed dramatically, I guess, in the years since I've been doing it. Yes, we've had some new techniques. When I was first in organic chemistry, we did a lot of carbonyl chlorides were a popular functional group we used to make, even though they were very reactive. So they didn't last very long. They weren't very stable. They were difficult to handle. They had lots of issues, and then people discovered coupling reagents, and we could use carboxylic acids, and now we a much more stable functional group, and we can use coupling reagents with those. So things kind of changed, and obviously then in the 80s we had sort of palladium cross-coupling chemistry, Suzuki and the sort of carbon-carbon bond formation.
That was the beginning of it. Yeah,
that was the big, that was, and obviously suddenly boronic acids and esters were really big in terms of functional groups. Yeah. I used to do a lot of chemistry back in the early 80s, distillate chemistry with tributyl stanol compounds that were kind of, I guess, earlier carbon-carbon bond functional groups people used to use, but much less kind of clean, a lot more. Obviously you have tin compounds and not nice. They weren't actually very nice to synthesize.
Is anybody doing that these days? Probably.
I think there are a couple of situations where you do need to use them because you just can't get the boronic compounds. They're not stable. Yeah. So occasionally they can be used, but for the most part they've obviously been replaced. So yes, there's been shifts in terms of organic synthesis, in terms of the sort of reactions out there. But I think much more importantly is how the compounds are used. There's so many sort of, as you said earlier when we were talking about the sort of the diabetes diagnostic and the toy, the breadth of organic chemistry. I mean, we recently introduced a range of organic molecules that are used in solar cells, organophotovoltaics. And I know you interviewed a lady from the KAUST University in one of these podcasts who was working in this kind of area. Yeah. And that certainly wasn't an area of research at all in the 1980s. So the uses for organic molecules and how they can be used continues to grow. Whether that be in the more traditional disciplines like the pharmaceutical drug discovery, or whether it be agrochemical research and creating better and cleaner, more targeted sort of herbicides and sort of right the way through to sort of new technologies. So the materials science, where we're kind of making kind of new materials, how we're using organic molecules in things like screens and and sort of foldable phones. Cell phones or mobile phones weren't a thing, but now of course a lot of organic compounds are are used in these kind of devices too. So I think there's so much variety and so much kind of new things to discover in organic chemistry that it continues to excite me all the time.
And it does the same to me. Yeah, you said it so well. Simon, you're a man of many stories, right? And yeah, you always, I could speak to you forever. And I just tell me one. In your 39 years of career, you have some funny ones, but why don't you pick one that it's worth remembering?
Okay, well, I will. Well, I mentioned the files early on, and you commented about there is a story there. As I mentioned, files are extremely smelly chemicals, and if you're working with them, then you've got to be extremely careful that you kind of don't get exposed. Otherwise, you'll end up, without any friends. And on this occasion, I worked with a lot of different files early on in my career. And the other thing to remember about files is that because they smell really strongly, they actually kind of knock out the olfactory nerve in the nose. So after a few seconds, you can smell the smell, but then the smell disappears. So as far as you're concerned, there isn't any odor. But of course there is. It's just that you are no longer capable of smelling it. And I must have accidentally, I think, spilled a couple of drops of a solution that contained a file onto my work boots whilst I was in the lab one afternoon. And so, I hadn't realized this. I finished up what I was doing. I jumped into my car. I was on my own, so there was no one to tell me that this had happened. And I drove the 30 or so miles back to my home. Now, at the time, my wife, I had two young children, and my wife worked in the evenings. We would, as many young families do. I worked during the day. I used to get home from work, and she would have fed the children, and then she would head out to work for the evening, and I would look after the children, put them to bed. So that was my job for the evening. So I got back, and now obviously. I would always take my work boots off. I wouldn't come into the house with the boots on. So I removed those, and often the first thing I did when I got back, having worked in the lab all day, was take a shower. So I took a shower, and after I'd taken a shower, then I say goodbye to my wife, and I got the children sort of ready for bed. At which point there was kind of a loud knocking on the front door, and there was someone from the gas company. And so I mentioned that these files are used in natural gas to give them the smell so that people can detect a leak. And my boots that had been sat outside the front door, they had actually, the smell from those boots, believe it or not, had actually wafted around the estate where we lived, was maybe a couple of hundred houses. Some neighbour had complained of the smell of gas. There was clearly a gas leak in the area. They'd sent an emergency response team out to scour the neighbourhood to see if they could detect this leak. And the guy knocking on my door was indeed someone from the gas company to find out whether I had smelt gas and indeed knew if there was any kind of gas leak. And so when I told him that, in all honesty, it was almost certainly my boots, that I was a chemist and I was working in a chemistry lab, and I worked with these compounds, and he was able to kind of prove from taking a quick to smell that this indeed was where the smell was coming from. So I was told to make sure that they were sealed away and they couldn't. So that was one story, and that was where I caused a major gas alert. But as you say, Paolo, there were several of those as you get over many years of doing chemistry.
Yeah, I started laughing early because I knew the story, and this is it's unbelievable, right? And it's incredible how it's probably been just a drop, right? And how bad that stuff can smell. And, you can get the smell in your whole estate, and cause an actual emergency in the town. It's kind of unbelievable. This is a funny story. Simon. Thanks. And after all these stories, all these experiences, in your 39 years, what takes you still out of bed in the morning? What excites you about your job at the moment?
Oh, I think is there are so many things. As I said, there's a combination of the research. I one of the things that I was really, I mean, I guess looking back, one of the reasons that I really felt, I guess I wanted to put the work in. As you mentioned, it was really tough actually when I started at Maybridge and doing the chemistry. But I mentioned that a couple of years earlier, my father had become very ill, and so I'd kind of had experiences of kind of of the impact of diseases and the impact they have on families. And so, kind of working in a kind of research environment where I was making compounds that, in some way, contributed to kind of solving some of those problems was really for me really exciting and still is
Right.
and one of the biggest. Although I wasn't directly involved, back in the sort of the late 90s, early 2000s, some of the chemists that I worked with, they were, worked with a company called Culis Pharmaceuticals, in helping to discover the drug olaparib, which is sold as Lynparza. It's an anti-cancer drug for a primary treatment for ovarian cancer. There's been a lot written about how successful it's been and how important a drug that is. And we played a small part in that, so that's something that I know everybody who was involved is extremely proud of.
Of course.
And that sort of came from the team that were there in Tintagel at the time, involved in that. But subsequently, there've been many other projects, and also the ability, and we've had a couple of years now with the pandemic where the travel's been a lot less. Last year, I started to visit customers, and I went to Stockholm and to Germany. So a couple of sort of small, but previously to that, to be able to visit customers in places like China, Japan, across America, all over Europe. That was something that I kind of, when I started in my career, would not have been imaginable. I grew up in a small fishing town. My father was a fisherman. I think the furthest he ever went in his whole life was London twice. I didn't travel abroad at all until I was probably in my 20s when I went to France. That was exciting. So to me, that the opportunities that the careers afforded me to be able to meet all these people, to see these different cultures, to experience
Yeah.
all of that. That gets me out of bed in the morning. That's
Yeah.
exciting.
Yeah.
What's the day going to bring?
Yeah. And yeah, there's nothing I can add. It's just beautiful to listen to you saying it, and with kind of the expression you have in your face. And there's a way, Simon. We always finish our interviews, and I know you've listened somewhat the other episodes, so you probably know what the question is, but I didn't tell you beforehand. So in theory, from my perspective, you're not prepared, which is what we want. We want you to improvise. So after all this experience, and what you've been through and what you've seen and what you know about the market, and and how you've seen your own career, but also the one of many other people and former colleagues and such. What would be a piece of advice you would give to someone just starting in their careers?
I think just take the opportunities that come your way. I mean, there's always a certain amount of luck. We talked about it, with everything, but at the same time, you do make your own luck to a certain degree. From my own perspective, I always kind of when we were asked to do things that sometimes were challenging. So I can remember, as I mentioned, that trip to Switzerland to give the first talk. I wasn't the most senior chemist in the team by any means at that point. There were others that had the kind of the first opportunity to go, but said, no, this is outside of my comfort zone. I'm not I don't feel there's something for me. And it was outside of my comfort zone, in all
Yeah.
honesty. And I thought, but I took the opportunity, and it paid off. And I actually started to get asked to do more things, and that grew. So I think maybe take advantage of the opportunities as they arise. But at the same time, and this is something perhaps that again from my own perspective, try and find something that you enjoy doing. Don't necessarily think that that you have to kind of reach a very senior position, or to have a job that just because of a title or whatever. It's something, for me at least, it's important to kind of like enjoy the job that I'm doing. I've been very lucky over close to 40 years to find myself doing a variety of different jobs. Okay, officially working for the same organization, but working in the lab, working sort of managing teams of chemists, then working in a more commercial role, traveling. All of that I've really enjoyed. um, but I've kind of selected, and there've been opportunities where I thought, no, that wasn't for me. That it might have meant, I don't know, some more money, or kind of a larger, or a bigger title, or whatever. But I felt, no, this is kind of what I'm. So I think for me, the advice would be to take advantages of the opportunities as they come your way. Don't be put off. It might seem scary. Some of these might seem scary, but they're actually, when you do them, it might turn out to be something that really you enjoy, and think, I want to do that more. But at the same time, also, don't feel pressured necessarily to have to progress in ways that you don't want to. And that's kind of been my advice.
And that's the best way to close. Simon, it's really great having you with us today. I speak to you very often, but not in this context, and it's really been fun. So thanks a lot. It's a great conversation.
Thanks, Paolo. And I've enjoyed it. Thank you very much for having me.